very much.
So let me just check, are you on the internet? Can someone check? Donald's desk.
They were all at the cinema.
So let him worry about the TV part.
Yes. Two together. Oh, action.
Yeah, absolutely.
Here.
And as they're coming up, first question is over. Second question, you're over. Not a bother? Brilliant. I'll put it on to home, I'll put it on to yes, thank you. And then I'll do as well with the do you want me to get involved?
I only bought an apple, that's all I think. Sure? Yeah. So, do you think I should have this kind of point just directly at the stage? Is this going to be directly just for asking questions before you get questions?
Yeah.
So,
It is. Yeah.
is there somebody controlling this one, sir? Or do you have it?
Well, I'm not too sure. Oh yeah. We're up here in the folks.
If you want to stay on.
Oh, okay, that's fine.
Oh, great. Yeah. Oh, yeah.
How's it going, alright? Yeah.
Is it nice? Is it worth it? Well, I tell you what, I was having a beautiful video call with us. It's an application. I'm sure that's not the first time I've said to you.
Another baby 8 weeks ago, so 3 now, 6 girls.
So I'm tweeting you now.
Now you're yet to get down, we're not.
No, I'm not going to put the video on. That is, I will
Guys,
find
do you
out.
want to say a few words? Do you want to say anything for the radio? Okay.
Okay.
Daniel should.
Daniel.
He's with RTE at the moment.
Okay. This guy. Okay.
Do you want to talk to these people,
No.
Seamus?
No.
Are we going to ring Belgium?
We're going to, in a minute, we'll ring Belgium.
Well, it's quiet now, like lunch.
Yeah, but then you talk to these people. talk to everybody.
Daniel, hi. I still haven't interviewed him, but I hope to. But I'll find him. Well, can I get you outside this door here?
Will I bring these gentlemen up if you're busy? I sent a few men up.
That's me done.
I need,
In there now. You alright?
yeah, get Grant. Thanks very much.
I saw Ian come in. It's not.
He went out that way, but I don't know where he went after that. No, there he is. Oh, sorry. Hello. You tell Paolo that we really, really appreciate it, but that really we don't want to take the risk. It has been very difficult getting the Swedish part of this put together. You understand?
Okay, go put your cape on. Go put your cape on. This is what you're doing to me.
Yeah.
Okay, hold on.
But if we have the ham,
No,
I know. Yeah, but how? I'm not clear how we can do that if we have LOS. We need to get the full pass for questions. You understand?
Sure.
That's the big problem because Sweden have the questions here. So we need a full pass, right? And you know, by the time Paolo goes from Zvezda back over to Columbus, it's going to take him a few minutes. And, you know what I mean? Yeah, but if you're talking to or you're emailing Paolo, please tell him we really appreciate it. Now, just say we have 1,000 students here in Dublin listening to him, okay? So, all right. Okay, thank you, Francesca. Thank you very much. I really appreciate it. Someday soon we will have a beer, okay? Ciao, ciao, Francesca.
Thanks, Darryl.
Looking at a video about
I'm going to hold my phone beside you to get a bit of sound. Is that okay? You don't need to.
Lads, do you want to come have a quick coffee and a sandwich? Are you all right there? Yeah. 4:00. Yeah, come on the way down to 7. You okay there? There's just a little bit of wire there to talk to.
Thanks very much for doing that. Brilliant. What about the two? Will I take one of the two?
I just get one of her first. My daughter is getting in, so I tried to get a photograph of her.
You know what?
My daughter is
Now, did anyone else want tea or coffee?
Yeah,
And
there's
sandwiches?
well, there's a gentleman up there would love a cup of coffee.
Will I bring it with me?
Well, yeah, let
Or
me.
will I bring it down to him?
Would you mind?
No.
No, I'd rather you brought it to him.
Right. So what's he going to have? Tea or coffee?
Coffee.
Sugar milk?
No sugar, milk.
And some sandwiches?
Maybe give him 2 sandwiches.
No
Kind
allergies?
of feedback, guys.
No, not that I'm aware of. I'm sorry. Listen, I'll go down with you and bring him back.
Not at all!
No,
Not
honestly.
at all. I'm able to use my 2 legs. Do you have anything?
I'll go down myself for some.
You want me to ring Belgium now?
Yeah.
That's it, me.
Good afternoon. Hello. Hello.
Where's the mic? Where's the mic? Where's the mic? Nick, where's the mic? Yeah, don't just look at me. Hello, can you hear me okay?
Yeah, I can hear you.
Yeah, sorry, I'm much louder now. Hello? 1, 2?
Yeah, 1 minute is fine.
Okay, I'll turn you up now. Can you talk?
1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3, 4, 5.
Yeah, so you're not too bad now. You're not too bad there, yeah. We're getting home from you, but that's okay. We'll just use you as a backup.
Okay.
So
I
yeah.
assume that I'm switched off during the contact and you make the last email say you connect me at the moment that you need.
Yes, so if you can send the audio from the ISS,
Yes, continue.
and if we say the magic word, the special magic word, then you can take over.
Yeah, we do that.
I'm afraid to say it. I'm afraid to say the words.
But I give you a little noise for testing my receiving. Is that okay?
Yes, yes, send me some audio.
Did you hear it?
Yes, yes, that's good.
Okay. For me it works. And I'll wait for your instructions.
Oh, okay, yeah, that's fine. Can we stay on the telephone line then from now on, like 1 hour, 2 hours?
Yeah, you can do that. That's for me. Take that, no problem.
Okay, so we might I don't know. I don't know what more testing we can do, so we'll just stay on the phone line now. Thank you, Jan, and sure, we'll call you again. We'll send you audio. I will continue to send you audio from Ireland. Have you looked at the website www.tangooscargolf.indiaecho? The website is tangooscargolf.indiaecho.
Yeah.
And we have live video on this website.
I'll watch. We have here, I have Skype also open, and I can stream also audio in Skype.
Oh yeah, okay, no problem, but we will use the telephone line. It's okay, no problem. No problem. Okay, thank you. I will turn down your audio now, so we are finished now. I will turn down the audio, but I will continue to send you audio from Ireland.
Okay.
Okay?
Yes, perfect.
No problem, thank you.
Yes, thank you.
Maybe ask the reporter, he know that. That would be a little mess. I haven't changed. I don't have to watch the face of the pot. You guys have to too busy to
Yeah, the dark.
you want to get down to the yeah, hopefully.
Matter itself.
Can I talk to you for a minute? What you did?
Are we doing questions cast now? Okay, well I will try to check it all down. Great. Yeah, and the kids that are knack. Oh, listen, thanks to me.
Sorry to be so long, I started around 2
Could you do me a favor?
That's and there's more up though. I go up and get out. Coming up, gentlemen.
Together, first we get together.
Yeah, you take these big ones, you just say you can leave.
Got you off the stage.
Brilliant. Thank you very Is this a live feed from the Jason?
I don't think so.
Yeah, you can see the equipment outside.
Yeah, there's a live feed.
Only VIP, yes. Now, you are going to come over here.
Yeah, great.
That's the
with photos on Twitter and the juveniles watch. So don't. Sorry? Well, that's the thing. When is she around?
She's here. Yeah, a few words at the end.
Fab. She's going to give a talk as well, I think. Brilliant. Fantastic.
Is it energy based? No. Okay. But I know that we discovered matter. So transparency. What's in the back? No, I thought they were okay, we know we're looking at
Hello, is that sweet?
For a long couple of minutes. Ladies and gentlemen, as you can see in the background, Ireland is getting prepared now for the cultural exchange. So you can see that on top here in the back.
You're ruining the surprise for yourself. Jupiter, Neptune, Uranus, and Saturn.
Yeah, generally 6 to 11 minutes.
I'm going to get some helping hands for those blinds, am I?
Yeah.
Yeah, that is great, guys.
Let's go lower the blinds there. Leave me.
Okay. Hello there, our guests. Very welcome up there. Oh, hello, Mr. Paul. How are you?
Hello, Sweden. Can you hear Ireland? Hello, Sweden. Can you
Ian,
someone's turned us down there.
no, nobody's at the desk.
1, 2, 1, 2. I think we're turned down compared earlier on.
You want to change it yourself here?
No, but I'm happy if you're happy, but I'm saying,
Wait, like, check the
I'm in the
gauge.
same volume. Yeah, maybe I'm slightly, geez, don't turn on that one. 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. If you're happy with that, I'm happy with that, okay? 1, 2, 3, 4, 1, 2, 3, 4.
Yeah.
Hello, Sweden. Hello, Sweden. Can you hear Ireland? Hello, Sweden. Can you hear Ireland? Hello, Sweden. Can you hear Ireland?
Perfect. Does that do
Hello, Sweden.
So,
Can you hear Ireland?
Yeah, no, honestly, a lot of them, like, for example, like this, like that's all the same.
Cool.
That's like very good. That is related to
Yeah.
the top one. Nice. Okay, perfect. Is it possible to put this on for so I can see a tiny result?
Oh, the timer is a good idea.
And I might just change it toward me and the back.
Yeah. I don't know really know it's like.
Just the timer's nice.
Yeah, we go 100 watts.
Get on there. Get a bookmark and
Yeah, Joe brought one and tested it.
oh yeah.
Is everybody wearing a mic? Yeah, where do you want us here?
Yeah, so you're
With the microphone?
I'll set up yeah. Read the front row, you know.
Where did you get This is so good. I'm so impressed.
Right.
Here, we can forget the bench.
And then just hover from here.
The main thing is the feedback is that it's got to be visual the chart out of the range of the reading of the scope of the chart. Can I ask, do you think it's possible for me to go up to the car and get my laptop and edit some stuff that I did earlier?
It's up, yeah.
Because to be honest, it's the talk, it's the scientific stuff, and the actual content, post-contact chat. Right. I'm not kind of extraordinarily excited about require that kind of stuff. You know what I mean?
You work away.
So what I might do is I might just go out and grab the stuff.
You work away.
Fantastic.
I think
back there, or I got well enough.
and just what about that? That's fine like that, yeah.
You're only first year. Sorry. The rest of the first year, not only knows what you need.
James, for your presentation, we're going to use this.
Oh, so when I finish my presentation, we have
See how far you get? Literally just ends on what I was saying. So where are you going to get? Trying to get to a certain
Yeah, no, 12 We're going to connect over now.
I think you have a minute spare.
I don't know. I'll check what it's supposed to be at.
Well, you tell me what you think.
You need to go more on the light now.
The light is shining forward. Is that what we want?
Well, you can adjust from here if you want.
Do you want to do it? So what I was going to say.
The sound.
So yeah, that's really okay. Yes, we have a
Actually, I just want you to take that picture.
this guy here.
But you're saying one is to fold the rest. Okay. Oh yeah, it's for later. See you later.
Testing 1, 2.
No idea. This way. Gentle focus, you go as fast as you can. Going. Very quick, go down to this apartment toilet. It's faster. You have to walk it. Go. This way, please, it's faster than that. I'm just trying to get people in front. Go. Faster than that, dear, faster than that. I'm shaking. Keep going. Faster than that, gentle focus. Go, lads, down the end. This way. More.
So we go to Waterfront tonight. It's not the live stream, is it?
Everyone's doing it. It's okay. Quiet, it's part of the atmosphere, right?
Yes, hello? Hello? Here.
Okay. Yeah, no, it's fine. Yeah. Okay, I need to get going here. I need to get going. I'm ready to go. Irish time. 1:45. So I am going first to the culture exchange. Okay. So 10 past 4. 10 past 7 minutes for school. I'll go first and then we'll pass those. Just be tuned in on the Skype. Yeah. Okay. Cool. I'm ready to go.
We're still going on.
Ready to go, yeah. Yeah. That's okay. Okay, people. Okay. Okay, guys. Right. Okay. Firstly, welcome to everybody. We have got T-minus 65 minutes before we contact the International Space Station. Okay. We have got a tight schedule here. Now, housekeeping rules here. It is really, really important that we are quiet, okay? Because the astronauts can hear everything we're saying down here, okay? We are also streaming live around the world, okay? So, we're on our best behavior, everybody's clued in, and we're T-minus 65 minutes away. Where's my two sidekicks? My two sidekicks here are going to be helping me present, okay? Adam and Liam. We're going to have some music from the choir, we're going to have some Irish dancing, and we're going to have some guest speaking, okay? I want to get the show up and running, so I'm going to pass you over to my two psychics.
So, welcome everybody to the hour leading up to the contact with the International Space Station.
We have plenty of entertainment to keep you busy, such as
some beautiful music from the school's choir,
3 wonderful speakers to talk to you about space,
and our guests from the Board of Management.
and of course a cultural exchange with the Swedish.
Now, here's a little secret about how we're going to contact the astronauts. My friend Liam here, with this helmet, is going to get Mr. Boren to throw him at the International Space Station. So, while we wait on that, without further ado, our first musical act.
Okay, guys, so we're going to pass over to our beautiful choir here. We're going to start off with our first song, which is Coldplay, Sky Full of Stars. Away we go.
I'm gonna give you my heart.
We're going to have 3 pieces from the choir today, so that was beautiful, nice big start for the show. Before I say and go any further, we have 2 live screens here. So during the presentation of the talk here, keep having a look up at the screen at the moment here. The ISS is currently just over Sydney, and you'll see the different shade and colours. It's obviously night time in Sydney, so you'll see the different shade. So what we're looking at is the next Earth track. Okay, so the next, as it passes up above Cuba, all the way across the Atlantic, and then we're going to be hopefully contacting them when it comes just above Ireland. And the big blue circle around it, that's our limit for our radio signal. So that's how far we can get our radio signal in. Okay, without further ado, I'm going to get the lads to introduce our first 2 speakers. So away you go, lads.
Our first speaker is Dr. Sophie Murray. Sophie, who completed a PhD with Astrophysics Group in Trinity College, Dublin, is now researching space weather, including solar flares and corneal mass ejections. Sophie works with the STERO spacecraft to try and improve our scientific understanding of solar systems and to provide accurate forecasts for server weather events.
Our second guest speaker is Aoife Ryan. Aoife is an astrophysicist. She graduated from Trinity College Dublin in 2015 with a BA in Physics and Astrophysics. Following this, she decided to pursue a Master's in University College Dublin on Space Science and Technology. This led her to a 3-month internship with a European Space Research and Technology Centre. Aoife is now currently a PhD researcher in the Astrophysics Research Group in TCD. She is studying solar physics using radio telescopes. Can you give a round of applause for Aoife and Sophie?
Okay, thanks everyone. I'm actually Aoife, not Sophie, so I'm not a doctor yet. As the lad said, I'm from Trinity College, and I'm doing my PhD there, basically looking at LOFAR. So may I get just a hands up, anyone that's heard of LOFAR or iLOFAR? Anyone? Yeah, we have a few in the front, but nobody else. That's why I'm here. I'm going to tell you all about it, okay? It's basically a radio telescope, okay? So I think when we all think of telescopes, we think of a big long tube, something you look through with your eye, and then you look up to the sky and you can see the planets, the stars, galaxies and stuff like that. So for me, it's slightly different. And how we do that is we first of all look at the energy. So all energy comes in waves, and all these waves are different sizes. So you can have some waves that are as small as 300 nanometers. So that's really, 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 really small. That's smaller than the thickness of a sheet of paper. It's tiny, okay? And these are actually the wavelengths that we can see. This is what we can see with our own eyes, these tiny, tiny wavelengths. So the energy coming in these really small waves. But what I'm looking at, what I need to see with my radio telescopes are these guys. So these go from millimeters to meters. So it could be even the size of this room. They're absolutely huge. And to use that, you need an antenna. I've used a little coat hanger here, basically a piece of metal. When the wave comes in, it vibrates up and down your little antenna, and this gets changed into a voltage. So this is the basic idea around a radio telescope. Of course, they don't look like this coat hanger. They actually look like this. This is it's called the Lovell telescope. It's in England, and it's an absolutely massive telescope. You can see there's some ladders and stuff going up, like a person would be absolutely tiny, about this size on the ground. And so the idea with this is the radio waves come in, they hit the dish, which is basically like a giant bucket for radio waves. It just collects them all in. And then they bounce all up here to this thing. It's the antenna. It's basically where everything is measured, where your coat hanger is, if you want to think of it that way. And then the idea with radio telescopes is bigger is always better. The bigger the dish, the more you're going to observe, the more you're going to see, the more waves you can catch, the more you can see on the sky. So we kept building these bigger and bigger and bigger until we hit some problems. This is a telescope in Greenbank, and this is what happened to it. So it basically was built so big. These pictures are taken one day after the other. It was built so big that its frame couldn't support it, and it ended up just crumpling to the ground. So one of the other ideas people had was, why... Oh, hello. There we go. I got this. Don't worry, I'm an astrophysicist. So one of the ideas was just to build them actually in the ground. So this is the Arecibo. This is 302 meters across. It's huge. It's absolutely huge. And you can see people can actually climb up onto these support structures just to do maintenance work. And these are cars here on the ground. This is huge. It's massive. The problem with this telescope is you can't point it. So the other ones could move, they could rotate to look at different things. This can't move. This is stationary all the time. This is not what happened to it. I don't know, does anyone remember the movie GoldenEye? Anyone seen that movie? Basically, James Bond kind of skated down the edge of it, so that's not what happened here. So the idea was that instead of building these bigger and bigger telescopes, we'd build many telescopes. So we build 2 smaller telescopes that can move and are not going to fall down or get broken. And they're as if there's one giant telescope. So you could have one telescope up here and another at the very end of the assembly hall, and it would make a kind of a synthetic telescope that is literally the size of this entire hall. So this makes things a lot easier for doing astronomy. This is an example here. So I actually went and visited this one. This one's really cool. It's called Westerbork, and it's in the Netherlands. And this is about 2 kilometers long. So you end up with a telescope that's 2 kilometers in size instead of just 300 meters. Here's another one. This is called the VLA, which stands for the Very Large Array. We're not very imaginative. We like to keep things nice and simple. This one is 36 kilometers. So it's getting bigger and bigger and bigger. So this brings me to exactly why we needed to build our telescope, LOFAR. So LOFAR is actually a telescope that stretches all the way across Europe. So it starts off here in the Netherlands, and they started building loads around the Netherlands, and then out to all these other stations around Europe. And then we built one in Ireland, in Birr. For those of you that don't know, Birr is in County Offaly, and we started building that station this summer. So that's what I've been doing for my whole summer, building this new station of this telescope to connect to all the other stations and to basically make a telescope the size of Europe, which is pretty cool. So this is what one of these stations looks like. It's not as pretty or as super cool as one of those big dishes. You're not going to see James Bond wandering around here. It's a bit boring when you look at it straight away. But it's actually 2 antennae, 2 types of antennae. You have low band antennae, which they observe frequencies before the FM radio, so the radio you listen to in your car or at home. And then you have these other ones. And these are the high band antennae, and they take all the frequencies above the radio that you listen to. And so that's what these ones here look like up close. And it's basically a pole with 2 cables in it. And these are the antennae along here. So these are your coat hangers, if you want to think of them that way. Or basically the part of the telescope that will shake when a wave comes in and then measure it. And this here.
30 seconds.
Yeah, 30 seconds, all right. This here is the inside of the HBA. So I'll just finish then. I know we're on a tight schedule, and say that basically students came from all over Ireland to build this telescope this summer, from every single university, from Cork, from Galway, Armagh, DIT, everywhere. And we all got this chance to build this telescope together, and hopefully we can do some really cool science in the future, which hopefully Sophie might touch upon.
Thank you very much. Thank you very much. Okay, we are on a tight schedule, guys. That's why we're going to cut a little bit short. It's now just over New Zealand. We're T-minus 55 minutes away. So it's just coming over to South Pacific over there. I'm going to quickly introduce to our second speaker here, Sophie. Sophie's going to talk a little bit about space weather, and space weather obviously affects it. So we've got a small little presentation here from Sophie, and then we're ready to go. So Sophie. There's a documentary on tomorrow night at 10:15 on the work that Eve has done tonight. Cool.
It's a very cool documentary, definitely. check it out if you have time tonight. So, you might. Yeah. So I want to talk a little bit about space weather. Now, as scientists, we all know about what this is, but it's kind of not a common topic amongst kind of your everyday person. It comes from the concept of weather, right? So you have your everyday conditions, sunny, cloudy, rainy days that will change on a day-to-day or a week-to-week basis. And then you also have more serious conditions, things like thunderstorms or snowstorms. And in a really rare event, like Ophelia on Monday when you all guys got a day off, you can have things like hurricanes. So you have your day-to-day changes in weather, and you have your really extreme events that are very rare and only happen maybe every few decades. And all that weather happens very low down in our Earth's atmosphere. So you're talking about up to an altitude of about 20 kilometers. The region of the atmosphere known as the troposphere. But it's really kind of often easy to forget that our atmosphere actually extends up really, really high. So don't worry about the terms here. You can see they go up for hundreds and thousands of kilometers. And it's the region in Earth's atmosphere where the International Space Station is, where our spacecraft are orbiting. So the changing conditions in our upper Earth's atmosphere in these regions is known as space weather rather than weather. And I want to talk to you a little bit about where this comes from. The source is the sun. So there's constantly particles streaming out from the sun into the solar system. And we're lucky because the Earth has a magnetic field which shields us nicely from these conditions. But it can still kind of travel along field lines and in the polar regions interact with Earth's upper atmosphere and cause all these different space weather conditions to form. So you see this green glow here. This is a really nice example of a typical space weather event. It's called the Aurora Borealis. So you guys might know it as the Northern Lights. So if you go up to somewhere like Iceland or Scandinavia or Canada, you might be really lucky to see these really cool light shows in the sky at night. That's your typical day-to-day space weather, and it's a really good example of how the sun is always active and changing and causing these changes to happen in our Earth's upper atmosphere. But we can also get extreme events. So just like on Earth we get hurricanes like Ophelia, we can get big extreme events on the sun as well. So they come from regions on the sun called sunspots. So you can see them here. This is a movie of the visible surface of the sun. You can see them traveling along these black dots. They're regions of really strong magnetic field. So as they evolve across the solar surface, they can change in shape and size and in structure. And some of them can get really big and complex and quite unstable. And in physics, if something's unstable, it wants to release energy. It wants to become a more stable state. And to do that, a solar eruption occurs. So this is your sunspot region. You can see it here, if I zoom in. This is the same kind of movie you saw, but instead of the surface of the sun, you're looking at the solar atmosphere. So you're looking at extreme ultraviolet light. And you see the zoomed in sunspot region here, but all this kind of brightening, bright flashes in the region. That's a solar flare. It's an emission of radiation in all directions from the sun. And of course, if this is coming out in all directions, it can impact us here on Earth. So you'll get interactions in the Earth atmosphere causing various different communication issues. So for example, if you have Google Maps on your phone, your GPS, global navigation systems might be disrupted because you can't communicate with the satellites very well when these extreme changing conditions in the atmosphere are occurring. You can also have radio blackouts, which is really relevant for you guys when you're contacting the astronauts today. But don't worry, there's nothing going on in space weather at the moment, so you'll definitely be able to contact them. Another type of eruption is a coronal mass ejection. So again, we have another movie of the solar atmosphere. You can see a sunspot region here. You see the bright flash of the flare, but there's some kind of stuff going off to the side. That's plasma. So it's the same kind of stuff that you have in your neon lights. So if you can imagine all this matter is directed out into space, and if it's in the direction of Earth, again, it's going to interact with the Earth's upper atmosphere. In this case, it's going to interact with our magnetic field and cause magnetic field changes, so you kind of get compass directions changing. You can also get things like power outages. But the most interesting aspect of these CMEs, probably for you guys, is you get to see the northern lights at southern latitudes. So it's an opportunity for you to see the aurora at really far south, even in Dublin, as long as it's not cloudy or rainy, which of course happens a lot over here. The final type is solar energetic particle events. So if you have a look at this movie, it's from a spacecraft that's pointing to the sun, and it's in between the sun and the Earth. You see this big field of view. There's a CME going off here, and then all this noise. These are particles bombarding the spacecraft. So if you can imagine you're an astronaut on the space station, you probably don't want to be bombarded by a bunch of particles. It's an extreme radiation dosage. So they're really lucky they can go into the space station where it's nicely shielded and safe during a solar storm. So they have to be really aware of these space weather events occurring to make sure they're not out on spacewalks when this happens. And it's the same thing with spacecrafts orbiting around the Earth. They want to make sure that instrumentation and electronics components are properly shielded. So it's kind of a topic that I think is becoming ever more important in our kind of technologically dependent society. And as we travel out and explore space more through the solar system, it'll become even more important for prediction purposes. Because we're nicely shielded by the Earth's magnetic field atmosphere, but out in space, we need to make sure that we have proper solar storm shielded areas. For example, when we're going out to Mars. So as scientists, we monitor the sun and we track what it's doing and we track the features and we use maths and physics and computer programming to create forecasts just like we do for weather forecasting. So I think you guys are probably going to be the first generation in the next maybe decade or so that will start to see space weather forecasts alongside weather forecasts. So watch this space.
Okay, thank you very much. Okay guys, it's a pity that we have more time, but look, as you say, now the ISS is just coming over the Pacific, so we're getting closer and closer, which is good. Now, we are now going to do our Eurovision bit, and we are going to contact Sweden via live stream. So, Tom, we get Sweden there online. So for this, let me just explain what's going to happen here. Will you make the live stream visible there, please? Bring up the Skype there, please. Okay, so Sweden are on the far right-hand side there. Hello, Sweden. So, hello, Sweden. Ireland
Hello,
speaking.
Sweden, can you speak?
So they're there, they're coming up there now. So we're going to kick it off here anyway with Darren, who's going to introduce Tallaght Community School of Sweden, and Darren's going to say a few words. So, hello Sweden, here's Darren.
A héanaí úsle, fáilte rád bhuaigh chuig Poblascúil Tallaght, go háirithe do Daltaí agus Múntóirí, Scoil Gymnasium Radnings Gymnasiat Sandal, sa Súlán. Is cuis mór an nóir dún a bheith cean de na céad scoileanna sa tír, chun teagháil a dhéanamh le spás éirí an stáisiún spás idirne siúnta, agus táimid ag súil go mór le teagháil a dhéanamh le Paolo Nespoli, níos déanaí inniu. Ladies and gentlemen, we would like to welcome you all to TCS, especially to the students and teachers of Gymnasium Radnings Gymnasiat Sandal. It is a huge honour for us to be one of the first schools in the country to make direct contact with the astronauts of the International Space Station, and we are really looking forward to making contact with Paolo Nespoli.
Okay, Sweden, we are now going to show you some of our Irish culture with our Irish dancing. So we are going to start a performance. We're going to show you some culture with Irish dancing. So are you ready to go with the dancers? Okay. Okay, Sweden, I hope you enjoyed that. That was a small bit of our culture, and it's fantastic. It makes us all proud to be Irish. I know I got that a really sense of being proud to be Irish. And we can see our great singing, we're making history in the school, and then we can show off our beautiful culture to be able to do Irish dance like that. So look, a round of applause there for the dancing there, please. Okay, now, where are we? Just to bring it back into the loop again, we're just coming up with an my geography. Mr. Keane, are we going up past Brazil, up around there? See the big yellow circle there? So the plus is Dublin. We've coordinated there with Seamus to put in Tallaght Community School. So the plus is Dublin. And that big yellow circle there is our radio signal. So hopefully we're going to start making contact just 2 minutes before they get out inside that yellow circle. Okay, the next part of our show, I want to introduce our principal and a very special guest here, Dr. Nora Patton. So the lads are going to do that for us there.
Then we have a welcome address from our principal.
And it's a great pleasure to introduce a very special guest, Nora Patton. She specialises in engineering and space with more than 10 years experience in the STEM sector. She's the founder of the International Space University, which specialises in using space as a means of inspiring the next generation. Dr. Nora Patton is just back from participating in Project Puzzle in Florida, where Nora participated in a series of pilot and training exercises to hopefully help prepare her future missions for space. It's a great honour to have Dr. Nora Patton in the Tallaght Community School today.
So we invite Professor Nora Patton.
Hello everybody, and I just want to take this opportunity. I am T minus whatever it is at this stage, and I know Mr. Bourne is watching me here, counting the seconds that I'm here, so I just want to take a very quick opportunity, first of all, to welcome you all here today. It's a very proud day for this school, obviously, making history, and it's a unique opportunity for all of you who are sitting here, and we're hoping that everybody around the school is tuned in and listening to the live stream. I just want to welcome our Board of Management here today, and I also want to welcome our guests from the primary schools. I hope you enjoy the event. I want to thank people, because that's what I do, it's my job, okay? And this would not be possible without the Trojan work done by ARISS, Amateur Radio in the International Space Station. I particularly want to mention Dan Cousins, who has been in here almost as often as I have in the last few days.
Dan, can you say hello there, Dan, will you?
Also want to mention in particular Seamus McCabe and Joe Ryan and the rest of the amateur radio team that are here. This would not be possible without all of the technical work they have done. And this week in particular, with the 2 days gone, and Monday and Tuesday, thanks to Ophelia, we were really under pressure yesterday, and I mean the work that was done was unreal. I just stayed out of the way, to be honest. I want to thank as well the speakers that we had here today, Aoife Ryan and Dr. Sophie Murray, for their very interesting talks. And don't forget, tonight that documentary is on. It's been advertised in the last few days. I've seen it myself. And now that you've had a brief introduction to it, give it a watch tonight. I just want to thank one other person here today. This would not have been possible without that man there, Ian Bourne. Also acknowledge, of course, Ian didn't do it on his own. He had a wonderful bunch of science teachers helping him out. I want to thank them, but also I want to thank all of the other teachers and all of the other students who put together this event today. Huge amount of work went into it, and we're really proud of you. And you're doing your school proud, and you're doing the country proud. Finally, I just now want to, I'll never do this again, I just want to introduce an astronaut in the making. Okay, I'm going to hand over to the experts here, Dr. Nora Patton. Thank you very much.
Thank you so much for having me today. It's really an honour to be here, and a huge congratulations to everyone who's made this possible. I'd say there are thousands of, if not tens of thousands of students that are very jealous of each and every one of you guys today getting an opportunity to speak with the International Space Station. As was mentioned in my introduction, I've just come back from a training program in Florida. I promise to come out to you over the next few weeks and share my videos and stories and take all the questions that you have, and I can't wait to share that experience with you. But there's one thing I want to say to everybody here. So when I was your age, I decided that I wanted a career in the space industry, and I made that happen. So for every one of you here today, you have an opportunity now to decide what direction you guys want your life to take, and I would say just go for it. Don't let anything hold you back, because now is the chance. You have this one opportunity, so make a good go of it, and get out there and do yourself proud for Ireland. So I look forward to seeing you in a few weeks' time, and enjoy today. It's absolutely fantastic.
Look, it's not every day we get an astronaut. Hopefully 2022, yeah? Hopefully 2022, which is about 5 years away. Look, I want to be an astronaut, too big for the capsule, so so look, the Russians wouldn't change the size of it, so look. I said that in live stream. Okay, right. We haven't got time to move this. So we're over South America now. So we're going to move on again. We have got our second musical piece, which is sung by Sinead here. Now, on the left-hand side of the screen here, have a look at the video it's playing. It's a nice few images, just thought-provoking where we're going in the next 10 years with space. It's a nice image clash. I'm going to hand you over to Sinead.
Fly me to the moon and let me play among the stars. Let me see what life is like on Jupiter and Mars. In other words, hold my hand. In other words, darling, kiss me. Fill my heart with song and let me sing forevermore. You are all I long for, all I worship and adore. In other words, please be true. In other words, I love you. Fly me to the moon and let me play among the stars. Let me see what spring is like on Jupiter and Mars. In other words, hold my hand. In other words, darling, kiss me. Fill my heart with song and let me sing forevermore. You are all I long for, all I worship and adore. In other words, please be true. In other words, I love you.
That is amazing. That is absolutely amazing. You know, I had the pleasure of teaching Sinead maths and TY, and look, that is your skill and talent. Perfect. You're fantastic there as well. Well done. Okay. Okay. Seamus has told me here now we got a little bit more technical. We're T-minus 14 minutes. Is a little. I didn't realise we can be more technical. Even we can. So T-minus 14 minutes there. We're beginning to hand over to the radio team. On stage we have our amateur radio experts. Seamus here, Seamus Cave is the director, head of the amateur radio ISS, and he's our main contact. Seamus is going to go through what's going to happen now over the next 15 minutes. He's going to go behind a small bit of the science of it, and again, he's going to have a few presentations just to show you what's actually happening. So can I bring Seamus to the stage there, please?
Hi, good afternoon everybody. I'm not going to talk for too long because there's a spaceship hurtling towards us at about 27,000 kilometers per hour, and it's moving really quickly and it isn't going to wait. ARIS is the amateur radio on the International Spaceship Program. It's a program that comes from various ISS partner countries, the USA, Canada, Russia, Europe and Japan. And it's designed to demonstrate at a practical level orbital mechanics, radio communication and items that are space related to students like your good selves. And so it's great that we have this opportunity, which is kind of unique, to be able to talk to an astronaut on board the space station. We are also, and it makes the thing a little bit more complicated technically, joined by a school in Sweden who will also have the opportunity, routing themselves through our ground station here to talk to the astronauts. Okay, the International Space Station, it's a habitable platform, it's a laboratory in space. It's about the size of a 5-bedroom house, to put it in context, but the wings that you see coming out of it are solar panels which produce all the electricity for everything that it's needed for, and they're overall about the size of 3 football pitches. So we're looking at a very big piece of equipment up there. It was brought up as modules in the space shuttle and with the Russian Proton rocket, and it was assembled in space. The first module that went up was called Zarya, and it was brought up on a Russian rocket in 1998. And so it has continued since then. The European Space Agency has a module and it's called Columbus. And there's an amateur radio station in Columbus, but that's not the one we will be using today. At the back of Columbus is the Russian module, Zvezda. And by the way, Zvezda in Russian means star. And you can actually see the International Space Station with the naked eye from Earth about 2 hours after sunset, if the sun is reflecting on it, and of course in this country if we have no clouds. And obviously it depends on the pass. And you can see that the astronauts, for example, have living quarters here. The amateur radio station that's in use today will be the one here, here in the Russian module. The antennas are built into the handrails, and this is a picture of some of the clamps that are used to keep the antennas in position. And again, the antennas are covered in a yellow foam so that they don't have no sharp objects which can puncture a spacesuit in space. Most astronauts and cosmonauts, they have an amateur radio license, and they're able to use the onboard amateur radio station to contact amateur radio ground stations and perform these school contacts. For example, this is the current crew. We have Joe Akaba, and he has an American call sign, and we have Mark van der Heij, and he has an American call sign, and there's Paolo Nespoli, who holds an Italian call sign. And he is an ESA astronaut, the European Space Agency, and he will go over to the Russian module to talk to us today, using the amateur radio station there. Amateur radio is truly international. This is a typical ground station. It looks much more impressive than what we have outside, but that's because what we have outside is portable, and we've constructed it today. And that man there, who's located in Southern California, very near where they had the fires, he's got a really nice antenna array. I just want to say 1 or 2 things, and nothing terribly technical, about orbits, because we have satellites that go around the equator. Now, 60 years ago, in fact 60 years ago this month, there were no satellites, no artificial satellites. And on the 4th of October 1957, the Soviet Union launched Sputnik. And that started the space race, and we are where we are today. And the satellite that sits around the equator is in what is called geostationary orbit, because if its angular velocity, and Mr. Boren will explain that to you in due course, is the same as that of the Earth. They appear to be stationary. And they're the things that you watch when you watch television, which are a fixed dish. There are also polar ones, which are used for, which go around the poles, and they get to view all of the Earth in kind of slices. And then there are a lot of other satellites, including GPS satellites, CubeSats, which have been put together by various radio amateurs and by various universities, and the ISS, which has an orbit inclined at 51 degrees. It means that it never really comes up over Dublin, for example. The furthest up it comes is about 51.7 degrees. So that's actually good, because if it did go over Dublin, we would have great difficulty tracking it. It would be moving so quick. It does mean that if you're up very far up in the northern part of, say, Canada, you cannot directly talk to the International Space Station. It covers an area of the Earth with a diameter of about 4,700 kilometers. So when we hear the first signal today, it will be half that. It will be about 2,000 kilometers away. And it will be at a height of about 400 kilometers. Now, what are radio amateurs? It's a service of radio communications for self-training, intercommunication and technical investigation and experimentation. And I need to warn you that this is an experiment. It may well fail today, but we hope not. To become a radio amateur, you have to have a successful technical exam, and you get a government-issued call sign or license. And Comreg issued these licenses, and they've given us the rather wonderful license of Echo India 1 ISS today, which is what we will use to call the ISS. IRTS is the National Society for Radio Amateurs, and you can look at their website and see what they do. And that's a typical radio amateur station. I think that one is somewhere in the States, but I thought it looked very good. And the man we should be talking to is Paolo Nespoli. Here's a picture of him taken in Star City, which is outside Moscow. And those of you that can read Cyrillic, the word behind him is Soyuz, because he was taken up on July the 28th this year to the International Space Station on a Soyuz rocket. And at any given stage, there are 2 Soyuz rockets parked, I use that word, parked on the International Space Station. So we will hear Paolo shortly.
T-6.
T-6. So now what's going to happen is, at about T-1 or T-2, we will start calling the space station. We need cuteness in the hall, please. We're all very excited, and we're as excited up there as you are down here. And hopefully after a few calls, we will actually hear the space station. And when we're sure we have established contact, we will start with the questions. Our antenna outside will be tracking the station, and hopefully when it appears a little bit above the radio horizon, we should be able to acquire the signal from that clearance. So, I think that's the plan. Now, when we're finished the questions, and when we feel we're going to lose the signal, the very important thing is that we all give a great big boulabus to the astronaut for taking his time to come along and to do this for us here today. So we will say in a very Irish way, thank you to Paolo. And now I'm going to go up there and we'll start getting things moving.
Okay guys, so we have got our students behind stage that are asking the question. I cannot stress this enough now. This is the most important part of the day here. The astronaut can hear exactly everything we're saying down here, so we need to have pure and utter silence, okay? There might be a bit of technical issues, so please be silent if that does happen, okay? And just listen to the questions. The questions are going to be up on this screen as well. Let's hear what the Swedish school are saying. Our questions will be up here as well, so it's really, really important that everybody's just silent for the next bit, okay? At the end of it, you'll hear the astronaut coming out a signal, okay? And then we're going to give a big round of applause to say thank you, okay? So, we are T-minus, how are we doing there, Mars?
Yeah, I just want to check that Sweden can hear us. Is Sweden there? Can you hear us? Is Sweden on the line? Can you hear us? Can we continue? You, Seamus, do you want to take the mic?
Keep calling there. Seamus, keep calling there.
Hello Sweden, hello Sweden, this is Ireland. Hello Sweden, this is Ireland. Hello Sweden, this is Ireland. Hello Sweden, this is Ireland.
Ireland, Sweden.
Hello Sweden, can you hear me? Hello Sweden, can you hear me?
Can you hear us? Can you hear us?
Hello Sweden, can you hear us? Hello Sweden. Hello Sweden, are you on the line? Hello Sweden. Sweden, we need to hear from you now, or else we...
1, 2, 3.
Hello Sweden.
Sweden testing 1, 2, 3, 4.
Yes, we hear Mark.
We hear you, Sweden. Do you hear us? Hello Sweden, hello Sweden.
Can you hear?
Hello Sweden, can you hear us? Hello Sweden. Hello, can you hear us, Sweden? Hello Sweden.
So we can hear you if you speak. Can you speak for 10 seconds?
1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
Hello Sweden.
Testing. Hello Ireland. 1, 2, 3, 4, 5.
Can you hear us, Sweden?
1, 2, 3, 4, 5.
Sweden, do you hear us?
1, 2, 3, 4, 5.
Oscar Romeo 4, India Sierra Sierra. This is Echo India 1, India Sierra Sierra. Over. Oscar Romeo 4, India Sierra Sierra. This is Echo India 1, India Sierra Sierra. Over. Oscar Romeo 4, India Sierra Sierra from Echo India 1, India Sierra Sierra. We do not hear you clearly quite yet, Paolo. Oscar for Romeo 4, India, Sierra, Sierra, Echo India 1, India, Sierra, Sierra, over.
Loud and clear. This is Oscar Romeo 4, India, Sierra, Sierra. Go ahead, over.
Oscar Romeo 4, India, Sierra, Sierra. You are loud and clear. Over.
Yes, I have you. Echo India 1, India, Sierra, Sierra. I have you loud and clear. Good morning, everybody. Thank you for preparing the cake for me. Go ahead with the questions.
Thank you, Paolo. We will start the questions now.
Question 1. What is your favourite view from the ISS? Over.
Well, it is very difficult to say because we see so many things, so incredible things that it's amazing. Of course, Ireland is very beautiful when there are no clouds. As it is England, I have to say though, my preferred is Italian. I'm partial. I don't know why. Over.
Okay, ask question 2 from Sweden. Seamus.
Question 2, please, Sweden.
Number 2. Hi, my name is Medina. Do you ever think children will be allowed to travel into space with astronauts? Over.
Medina, well, that's an interesting question. There are a little bit of problems here in space because of high radiation, and but I think once we know what are the problems, we will find a way to have everybody flying in space. And a good thing is that children don't stay children for long, so when they're adults, can really surely travel to space. Over.
If you had the chance, would you change or add anything to the design of the ISS? Over.
Well, there will be a lot of things that we could do here. Of course, this is a very nice laboratory. I would actually add kind of a cupola that looks over the sky in the direction of the space instead of just the direction of the Earth. I think that will be very interesting. Over.
Go ahead, Sweden.
Go ahead, Sweden. Go ahead, Sweden, ask your question.
Question 4. My name is Anton, and I wonder, is this the most difficult job you have ever done?
Over.
No, sorry, I didn't copy the question. Say again the question. Over.
Question 4. Is this the most challenging job you have ever done? Over.
Yeah, well, it can be challenging at times. I've been, I would say yes. So far, I would say yes. Over.
Question 5. What is the longest time you have spent on a spacewalk and what did you do? Over.
For ISS, Echo India 1, India, Sierra, Sierra. Question 5. What is the longest time you have ever spent on a spacewalk and what did you do? Over.
I know people have been outside spacewalking for 8 hours. Tomorrow we will have more. Exchange some antennas and some lights and some cameras outside the station. Over.
Question 6. Does the ISS have a black box like an aircraft? Over.
No, actually there is no black box per se like an aircraft, but ISS has a lot of sensors and data from all over the station are collected both here on station and on the ground. So there are multiple black boxes all over the place. Over.
Question 7.
Who inspired you to become an astronaut?
Hi, it's my...
Well, I was watching the astronauts on the moon when I was a kid, and that's where my inspiration to become an astronaut came from. Over.
Question 8. Have space experiments resulted in something useful which is used on Earth? Over.
Actually, yes. Many. I mean, everything that we do here on the station is done so we make life better on the Earth, and many things have been found here. And if you go on internet and you Google for space station spin-off, you will find a lot of things. Over.
Question 9. What training did you do to prepare for spacewalks? Over.
Well, we do a lot of training. There's a huge pool in Houston that we can use to simulate underwater weightless environment. But we have done also some strange training, like in Case in Italy and other places. Over.
Question 10. Have you ever encountered an anomaly that has baffled you? Over.
Well, actually, every day we encounter anomalies that baffle us. Either we cannot find something, or some piece of equipment doesn't work as it's supposed to, or some kind of experiment. We are in the discovery environment here, and every day we discover something, a lot of things new, and a lot of things that we did not foresee. Over.
Question 11. This is your third trip to space. Did it take your body more time to adjust to Earth's gravity the second time you landed? Over.
Well, I think it took a longer time the second time because my second flight was a long duration mission, about 6 months, and the first one was only 15 days. And of course, the changes on the body in 6 months are many more than in 15 days. So I'm looking forward for my third come back and see what happens. Over.
Question 12. What education in physics and engineering is required to become an astronaut? Over.
Well, today for being selected as an astronaut, you need to have a technical degree, but it could be anything like oceanography, it could be medicine, it could be just anything that has to do with technical things. So you need to know the basics, physics and engineering that are taught in the basic university courses. Over.
Question 13. When your mission is complete, what will you miss the most and least about life on the ISS? Over.
Well, I will miss this sense of flying around like Spider-Man, like Superman. I will miss the view from Earth, but also the least is that I keep losing stuff here. It's easy to lose stuff when you're working and you miss things, and this is frustrating. Over.
Question 14. Does your view of life change after seeing the Earth from another perspective? Over.
Yes, thank you. Well, this experience is it's very strong, and actually being up here, looking at the Earth here, it shows that sometimes we are too close to the problems, too close to the Earth to see things in a different way. So the perspective, the visual perspective here also is a life perspective. Over.
Question 15. Can you tell us about some of the interesting experiments you are conducting on the ISS? Over.
Yes, we do many things. I was doing some technological experiments with new hardware. I was doing one experiment that is actually checking what is the core of the Earth is doing. This is very interesting to me. But you're doing also experiments with animals, with plants, with all sorts of things. It's really 360-degree laboratory. Over.
Are you allowed to bring along private things like family photos? Over. Question 16. Are you allowed to bring along private things like family photos? Over.
Yes, we can bring a few little private things like photos, like mementos from Earth, mostly because
Hello, Paolo, Oscar Romeo for ISS. We are losing your signal now. Thank you so much. Everybody, through the bus.
Okay, guys, that was fantastic. And look, that there is the magic and beauty of science. We're live there, didn't work all around, but eventually we got it to work, which was absolutely fantastic. What we might do here now, if you don't mind, is we might ask the questions that weren't asked. Just final off. We just want to finish off the last two. So we got the last few kids ready on? Guys, we'll get them up on stage here. Yeah, and I asked us one or two of the experts to come up. So Nora, could you come up for 2 seconds, please? Sophie, Aoife, could you come up for 2 seconds, please? And we might just finish off the day by just asking a few extra questions, and then where's Miss Glynn? Where's the? You all right? Okay, so you just come up here on stage.
I hope you all enjoyed that. And it's rather strange because the amateur radio part of it, as you could hear, worked perfectly, but the telephone service kind of let us down. But that's what it's about. It's about experimentation. It's about learning. That's what science is all about. And it's wonderful to see you all here and to hear the answers coming from Paolo Nespoli on board the International Space Station, about 400 kilometers or so above the surface of the Earth. Okay, where are the questioners gone?
Yeah, 2 seconds, get them there.
All right.
Oh, here.
They ran away.
Yeah, I'm gonna get. We got the.
Here it is. Right.
So we might just look in picking the questions we sent out to primary schools. I got about 400 questions that throughout kids writing in my class, through all the other science classes. So it might just be nice when we have experts here just to finalise a few of the answers that a lot of questions we ask here. So we might just pick 1 or 2 questions and we might pass the mic on to one of our experts. So go ahead.
Question 21. In recent weeks there have been some terrible storms in America. What is it like to see a hurricane from space?
Right, so we're going to ask Nora to predict what she thinks it looks like, because she hasn't been to space yet, but look, come on.
Okay, so seeing as I haven't been to space yet, I've spent many hours looking at photos and videos from the space station. So you can see a load of things on YouTube from footage that the astronauts have taken on board. They have this massive big window that they can look out on the Earth, and you can see huge big weather fronts of like lightning, hurricanes, all different types of weather fronts passing over different continents. So go to YouTube, they're all there and you can see them for yourself.
Okay, cool. The next question Lee is going to ask is question number 25. What do you think?
What do you miss the most from Earth when you're on board the ISS?
I'll ask Aoife. If you were on the ISS, what would you miss the most?
I think I miss like takeaway and telly, and I think most people would miss like normal food, wouldn't you? Because you have to eat all those mad things that are packed. And I know if you ever seen astronaut ice cream, and it looks like this kind of vacuum packed. It looks miserable. So I definitely miss Ben and Jerry's and things like that.
Right, we're going to ask a biology question. Okay, away you go.
Is the space station sterile and, as far as possible, free from bacteria?
Yeah, Sophie does.
As far as possible, yes. So, as far as I'm aware, astronauts do have to go into quarantine before they go up to space. So they will, I think, for a week or two beforehand, they want to make sure they don't get any colds or anything like that before they go up there. And so, yeah, they make sure they're as quarantined as possible. So it's probably very, very, very clean up there. Who knows?
Right, we have 2 of our primary school students here. They're going to ask a question. Do you want to come forward? As Nadine, is it? Cool.
My question was, if NASA returned to the moon, what type of research would be done?
Great question. Nora, let's have a look and see if you answer that.
So they're already planning, they're already doing lots of different research before we go there. So they're looking at how we can use, it's called regolith, that's like the dust that's on the surface of the moon, how they can use that to build new structures. The European Space Agency are doing a lot of research on it already. So all that work is done in advance, and then hopefully when we do go back to the moon, it's a case of using all of that knowledge that you learn in advance and making the most of the time there. So it's already in progress.
Cool. Who do we got next? Thomas, where are you from? What primary school? St. Kevin's. Right, Thomas, what's your question?
What types of training have you done so far?
Nora, that's back to you again, yeah.
I'm popular on the mic today. So I just got back from Florida actually, just last week, and it's called Project Possum. So it's basically to become a scientist astronaut. So over there we looked at, we did spacesuit training, so we worked with a company who are designing a spacesuit for NASA, so we got to try it on and pressurize it up and see what it felt to work in it. We did like high G flights, so G is like a force that's on a body. We did it up to 4 Gs, which was like 4 times my body weight on my body, and it was squishing my body, so I could see what it was like to experience that. That's what you experience during a launch. So different things like that, and next year I'll be doing more training to make it further. So all of these things you do in advance, so that hopefully when I eventually get to space, I'll have all that practice done.
Cool. Right, who we got next? Jamie, what primary school are you in? St. Kevin's. Cool. What's your question?
What would it be like to live on Mars?
Eva or Sophie? Which one wants to take that? Sometimes those teachers think we live on Mars in here as well. So.
There's lots of things you have to think about with Mars. Mars, I'm gonna give a space weather answer. So Mars doesn't have the nice magnetic field that the Earth has to shield us on Mars from all that solar radiation. So we have to be very careful, probably live in shielded capsules to make sure we're protected and we don't get increased radiation dosages. And of course there's loads of plans about things like terraforming Mars and bringing plants over and making it nicer. But probably making sure we're protected from the sun is going to be the biggest thing about Mars.
Okay, Lee, you ask one more. We ask question 51.
What does space smell like?
Who wants to answer that? Last one, you're going to answer that one.
Well, space is just a massive vacuum of nothingness. So I'm guessing it would smell like nothing. You also can't hear in space. If there was an explosion to go off in the middle of space, anyone would not be able to hear it. You can only hear it when it travels through air. So space is a really special kind of environment.
Okay, cool. I have one more question for Nora. Do you think they're going to make the ISS a little bigger for people like me? Okay, cool. We're a round of applause there for Okay guys, right, we're coming to the end of our show. I want to finish off with 2 things. I want to finish off with a choir piece, our last piece, Rocket Man by Elton John. And in this video, if you look at the video and this song is playing, there's a lot of images from Mars, what NASA's doing, where we're going in terms of space and where we're going in the future. So have a look at the video there. The second thing I want to say here is a big thank you to the amateur radio team here. We'll give them a round of applause after that. But I'm going to do it later. I'll do it later. Okay. So we'll introduce our choir here from Rocket Man. Hashtag Inhor. Okay, so give us quiet please again. Okay, so this is our last musical piece, and we're going to introduce, we're going to sing Rocket Man by Elton John. Take it away, guys. Okay guys, we're coming near the end of our event. which is a pity. But look, there's a couple of reasons when I started doing this 3 years ago. You know, when you're in school, sometimes you don't always remember me teaching maths class. Sometimes you don't remember me talking about functions, or whether it's bacteria or whatever it is. But I hope today everybody comes out with something amazing in their head to say, listen, look, you can now go to the moon, Mars in 2022, 2024. I want you to think of a name called Elon Musk. Now, Elon Musk, guys, is an American who made PayPal, and he is the co-founder of SpaceX, which is a company which is going to transform space in the next 10 years. The hope for me today for this whole project was to give you an insight into what life on board the ISS is, and more importantly for you to think whatever career path it is, to start thinking ahead and saying what you want to do. This day wouldn't be possible without the help of the science department, so can you give a round of applause for our science department? I also thank the music department. Can you give a round of applause to music? It's absolutely fantastic. The staff, I think I owe all the staff a point, so at this stage, but listen, thanks very much for all the cooperation. What have we now done? But the most important people that made this work, and with all the technical issues and all the work, and being here at 6:30 this morning, we're a crowd of volunteers. We must remember these people have daily jobs, and these people are volunteers, and they give up their free time to work at our school. So the most important people, I'm going to invite them out on stage, please, is our amateur radio team. So you come on outside with us. We're going to be round of applause for our amateur radio, please. Don, do you want to say a few words? I can put Dan on the spot here. Dan, say a few final words for the show, and Shane, say a few final words.
Okay, I'll try not to break the mic. Yeah, so 3 years ago I started this little quick project, and 2 years later we had applied, and then we were rejected the first time, and it was a lot of work involved. I know I've been spending a lot of time. I know especially Ian, we met him on the evenings and the weekends, summer holidays, over and over again, and I think we must have exchanged at least one message a day for the last 3 or 4 months. So that gives you an idea of the amount of work involved. And as you noticed, the actual space station contact's only 10 minutes long, but we made a big event out of the whole thing, and we only did the 10-minute part. All the rest of it was all the rest of the team involved. So I'll pass it over to Seamus if you want to say a few words.
Thanks, Dan. I think it was wonderful, Ian. Thank you for your dedication. I just remarked in an interview out there, it's wonderful to see such an interest in science and technology and math here in the school. And you will know one thing, that when you leave here with your leaving cert or whatever you choose to do, you will have had a wonderful education, because one of the things about this country is that the education is as good as anywhere else, and you can hold your head up with graduates from Harvard or MIT or any of these fancy places. And that is thanks to the education that people like Ian and his fellow teachers give you. You may find it all terribly boring, the whole issue of mathematics and, theta and other Greek letters. But, that is the way of the future. This country, and indeed industry, needs people who are from an engineering, physics, computer science type background, because that's the way in the future. As I said earlier, 60 years ago, I stood and I looked up at Sputnik. Now, it probably wasn't Sputnik, it was probably part of the rocket that brought up Sputnik, because Sputnik was very small. but nevertheless, you know, and there was no cellular phones and so on. So if you move forward 10 years, you know, we will have the Internet of Things, we will have unbelievable connectivity, but all of that needs expertise and support. Thank you to Ian for having us. I think we all enjoyed it. The team here, as Ian said, gave up their time, their effort, and so on to do this. That, by the way, is what amateur radio is about. I spoke to my equivalent in Sweden. He's a little disappointed, but he too understands that this is an experiment, and experiments aren't always 100% successful, and we will all learn from that for the future. Thanks, Ian.
Okay. Now, and everybody listen up here now, very big to the students here. There's a lot of us here. We're all not going to stand up here now, we're all going to sit in our seats. Where's Mr. Glynn? Do you want to direct us up here now how we're going to move our seats? So everybody's going to sit at the back, we're going to move out from the back to the front, everybody else stay where you're sitting. So away we go there back to class in the back. So stay sitting.
picture of all our staff. If you want this in a shot as well,
Sorry. See that light?
Are you getting in? This could take a while. I don't know how you take photographs all the time. I'd be shouting at people. No, it's not the back. I'd be just like, for God's sake, will you stop messing around? Will you all look? Will you all look? They can take photos of small children.
Sorry. Thank you.
Okay, Michelle, are you ready? Get in, yeah. Nora, we need to see it. Maybe go. Can you go over beside the astronaut? Is that terrible? No. Can you see? And Michelle, will you get in? Some of the science departments, for God's sake.
Yeah, I just wanted to.
That's brilliant, Reid. Brilliant.
Is that the question?
Okay, hold on, hold. You, Regina's department, will you just let us take a photograph?
Yeah.
Look at that. Woo!